Are you there?
Yes, good
Yeah.
day. Hello.
Welcome. And it's you are going to talk about the interesting topic, policies. Oh, okay. Welcome to that. You can share your slides.
Yes, good morning, good afternoon to everyone. Thank you for the introduction and it's a pleasure to be here. I'm just trying to figure out how to share my slides. Unfortunately, I don't see the share screen button.
Okay. Oh, okay. Can anybody can help her, Karthik, sharing the slide?
Bottom you have, there is next to the the video, next to the video
Okay,
camera, there is a
got
screen.
it.
Yeah. Screen share is there. Screen share is there.
Can you see my slides now?
No, not yet. Are you? Yeah. Now we can see, I think.
Okay, perfect. Thank you very much for helping me.
I think, okay. You can make it to the full slide, full
Yeah,
screen.
I will do that, thanks, because I have to
Okay.
unpin audio. So the next
Okay.
speaker, Matthew, also here. Matthew, you are in right place now.
Okay.
Just wait for your round, your turn,
Okay.
okay?
Okay.
Yeah.
Okay, perfect. Just to tell you a little bit about myself. So my name is Elena Buzzi. I'm a research associate at the Environment Directorate of the OECD. The OECD is an international organization that advises mostly OECD member countries, but in some cases also partner countries, on policy recommendations and guidance on a range of topics. Specifically, in our team, we work on topics related to the transition to a circular economy. And lately, in the past few years, also we have done a lot of work on plastics. So what I'd like to talk to you about today is a line of work on microplastics that has been ongoing in our team in the past maybe 2 years, and that concluded just recently with the publication of a report that you can see on the screen on the right hand side. So this was a project sitting at the interface between our work on plastics and the circular economy, and the work in another team still at the OECD on water quality. We decided to work on this project on microplastics because we realized that this is a topic of emerging concern in OECD countries. And the objective for us was really to try and identify policy guidance for policymakers on how they can minimize microplastics pollution and the risks for human health and ecosystems. So as a disclaimer, my presentation will not be really about the science, because that's not what we work on, but more about, taking stock of where we stand on the science and say, okay, what are the solutions to the problem? What can policymakers do? What can industry do? And the report that, as I said, was published last month focuses specifically on microplastics that are emitted from textiles and tires. I will explain in a moment why we decided to focus on these two sources, but essentially it's because of their substantial contribution to the overall releases into the environment, as well as their low policy coverage. But I will show this in a moment in the next slides. In terms of geographical focus, we try to really focus on OECD countries. However, we also try to take into account the perspective of major textile producing countries such as India and China. And lastly, I should also mention that our work was informed by several consultations with experts and industry, including through 2 workshops that were organized in spring 2020. So the starting point for our project was really the recognition that microplastics pollution is an emerging reason of concern for ecosystems and for human health. What scientists were telling us in terms of environmental and human health risks was first that microplastics are everywhere. They're widespread in the environment, all types of marine, freshwater environments, soil and air, and are somehow contaminated with tiny plastics particles or fibers. These persist obviously for a long time in the environment. They accumulate in natural habitats, and wildlife as well as humans are regularly exposed to them. In terms of actual hazards for health, well, we know that some laboratory experiments have shown that the ingestion or inhalation of microplastics can induce adverse health effects in aquatic biota, for instance, although there are still large uncertainties with regards to actual exposure and the actual thresholds at which potential risks may occur. However, in general, in light of the potential risk for ecosystems and for human health, if emissions continue to increase, and also in light of the persisting knowledge gaps, scientific research has advised that governments take mitigation action to reduce overall plastics leakage and prevent risks to aquatic ecosystems and human health become widespread. Of course, then, if we turn to looking at a solution to the problem, we realize that this is a complex challenge, really. There are a wide variety of sources. Some are manufactured, like microbeads intentionally added to products. Some are just unintentional released during the use of products. Think, for instance, of particles from tires or fibers from clothing, from garments and other textiles. And others as well originate from the fragmentation of plastics that has already leaked into the environment. In addition to this, you also have to add the complexity of the variety of entry pathways that microplastics and plastics can take to enter the environment. On microplastics, we know that wastewaters, for instance, can be an important pathway. Wastewater treatment plants can be largely effective at retaining microplastics. However, you don't have the same infrastructure everywhere in the world, and at the same time, even if you do, there is still the issue of how you handle sludge and the need to understand the fates and impacts of microplastics when you apply it to agricultural soil. You also have a range of diffuse entry points that you need to take into account: transport by wind, rain, road and stormwater runoff. So it's a complex issue. And there's 2 points that I'd like to make to you in the next 2 slides in terms of where emissions are occurring from, which macro regions and which sources specifically. So this first graph shows emissions of macro and microplastics. Macroplastics in violet and microplastics in red. And the data is presented by macro region. It's from a UNEP report that was published in 2018. And what we see from this graph is that although emissions of macroplastics are mainly occurring in emerging economies, or at least in macro regions where most emerging economies are, for microplastics emissions, in fact, this is an issue that's occurring everywhere. Both non-OECD and OECD countries are contributing substantially to microplastics emissions into the environment, signaling that this is really an area where all countries will need to take mitigation action at some point. And then the second graph that I'm showing to you here gives the rationale for why we focused on textiles and tires only. So this graph shows current data and estimates that are available on microplastics releases by source for each macro region. And what we can note is that textiles and tires, again, according to available data, they contribute to between 1/2 and 2/3, depending on the estimate, of total global microplastics releases to the environment. This is if we exclude the degradation of microplastics. I'm only talking about the emissions of microplastics already in the micro size here. Why is this the case? Well, for tire wear particles, high emissions occur more or less everywhere, but especially in regions where OECD countries are concentrated, or at least in OECD countries, tire wear particles constitute a large share of the emissions in those regions. This is mainly because tire wear particles enter the environment through diffuse sources, through stormwater, for instance, and stormwater is not generally well captured or treated before discharge into water bodies or into the environment. For microfibers originating from textiles, emissions tend to be high in countries where the existing wastewater infrastructure is not particularly effective at retaining microplastics. However, there's an important caveat there. Even when microfibers are retained during wastewater treatment plants, because the infrastructure present and available is particularly effective. As I said earlier, we know that the practice of sludge land spreading, which is common in several OECD as well as non-OECD countries, may be redirecting the captured microplastics into terrestrial environments in large quantities. So this is essentially the reason why we focused on textiles and tires only. We noticed that this was an area where not much research and policy analysis had been done yet. And the second aspect that we looked at when we decided to focus on the topic was that, in fact, these two sources had not yet been targeted by policy yet. So if we look at the policy context here, I'm focusing on mostly on OECD countries because that was the focus of the report. But yeah, what we see is that in recent years, there has been increasing interest and policy action aimed at reducing plastics leakage into the environment, notably with bans on microplastics contained in cosmetics, bans on single-use plastics that frequently end up littered and end up in the environment, as well as through general improvements in waste management practices. And although recent policy action is likely to mitigate some leakage sources, in fact, microplastics that are emitted unintentionally during product use, for instance, textile microfibers and tire wear particles, are not yet generally targeted by existing policies. This is mainly because this is a complex issue. There is no simple technological fix or substitution alternative to prevent the emission of microplastics during the use of products that are made of plastics. It's an area where mitigation solutions are being developed and tested, and where policymakers still need support from stakeholders and experts in finding and designing policy solutions. At the same time, we noted that this was a policy area that was emerging. There were several countries that were interested in understanding what other countries were doing. What could have been some preliminary policy guidance for them. Some emerging policy action includes, for instance, the fact that several countries are mandating and funding research both on the presence of microplastics in the environment and the associated risks, but also on identifying and assessing mitigation measures. Several countries are also fostering the development of standardized and harmonized methodologies. For instance, in the EU, at the moment, there is work ongoing to develop common test methods for a measure for tire tread abrasion, also with the vision to include then these microplastics into existing legislation. Other emerging action includes awareness raising and consumer education initiatives, as well as in some countries, some regulatory measures such as standards for washing machines requiring the use of filtering technologies for microfibers emitted from textiles. So now I'm turning to the policy insights that emerge from our report. Just a second. Okay. Turning to solutions. So what our work and our consultations with experts have shown is that microplastics emissions occur and are influenced by all stages of the life cycle of products, of textiles and tires, which implies that there are a number of available entry points to mitigate emissions occurring along the life cycle of products. In our work, we try to pin down all mitigation best practices and technologies that have already been identified. I'll try to name just a few, but essentially at the level of design and manufacturing stage. What we noted is that researchers have identified large differences in microplastics, in the rates of microplastic shedding across different products, both for textiles and tires, which implies that there is a large scope for improving the design of products so that they release less microplastics during use. There's also some potential for the eco-design of complementary products and infrastructure. Think, for instance, of not only tires but vehicles themselves. Vehicles can be manufactured to be lighter, and lighter vehicles, weight is directly related to the rate of emissions of microplastics from tires. So if you reduce the weight of a vehicle, you also reduce the amounts of microplastics being released. You can adapt the design of road surfaces and the structure of roads, or you can fit filters onto washing machines, for instance. Another area for intervention still at the level of design and manufacturing is the prevention of industrial emissions of microplastics. This is a concern mainly motivated by the finding of textile fibers in wastewaters coming from manufacturing plants along the garment value chain, and the fact that researchers have noted that the majority, or at least large quantities of microfibers, are released from clothing during the first few washes, indicating that possibly those could be residuals from manufacturing. So an area that could be investigated further is, the degree to which action can be taken at the level of at the manufacturing sites or before clothing is put on sale, so that microplastics are captured at that life cycle stage before they go on to consumption. During the use phase, a lot of several best washing and care practices have been identified for clothing, such as washing less frequently, washing at low temperatures. Technologies are being developed, as I said earlier, for instance, for filters for washing machines. The challenge there, of course, is about setting the right criteria to assess the effectiveness of these filters and the potential trade-offs that they may entail with regards to other relevant environmental objectives. At the end of life stage, I'll just mention the case of rubber infill. Now, as most of you may know, one of the recycling options for tire rubber that can no longer be used in new tires is the production of rubber infill, which is commonly used in sport pitches and other applications. But there is evidence that these rubber particles can leak out and end up in the surrounding soil and water stream, further contributing to microplastics pollution. So another area for intervention that we identified is, implementing a set of mitigation measures during the design and use of, for instance, synthetic sport pitches. At the end of pipe stage, there are a range of interventions that you can take to prevent that the emitted microplastics end up in the environment. One of them being upgrading wastewater treatment technologies. The main constraint there being the production of more polluted sludge. And on the other hand, the better capture and treatment of road runoff and stormwater. In terms of actual policy guidance, first of all, a life cycle approach is definitely recommended. We know that action upstream and reduction at source are likely to have the largest mitigation potential, although at the same time, it's unlikely that this can entirely solve the problem, and some solution may not already always be available or tested. So some action downstream will also be needed as a last barrier to prevent the leakage of microplastics into the environment. This is especially the case for diffuse sources of microplastics, such as tire particles, which are difficult to capture once emitted. So a range of different types of policy instruments are needed to mandate, incentivize, or encourage the uptake of mitigation best practices and technologies. This is my last slide. I'm almost done. So in terms of more advanced policy guidance, there's 3 key messages that we send to policymakers. The first one being that, because there's still significant uncertainty around the emissions and impacts of microplastics from textiles and tires, and on the availability and cost effectiveness of the mitigation options, it's important that policy continues to support research and development in these 2 areas. And to this end, the promotion of international and interdisciplinary cooperation and information sharing, as well as the development of standardized methods, will be key to the advancement and acceleration of research. On a second level, we know that despite the need for further research, there are already several opportunities for no regrets interventions. So interventions where, measures driven by other policy goals can also give co-benefits for microplastics mitigations. I'll just give you the example of tires, for instance. We know that reducing overall passenger vehicle use, incentivizing the production of lighter vehicles, can lower greenhouse gases emissions and air pollution, but we also know that it lowers microplastics emissions. So, by taking action in an area where it's already agreed upon what we need to do, we can also generate synergies and lower microplastics emissions. On a third level, there are also policy tools that can be considered to target microplastics specifically, or as part of a broader policy framework on plastic and microplastics mitigation, either to reduce emissions at source. Think, for instance, of policy instruments such as minimum standards, labeling and information schemes, that could be introduced when further data and test methods are available, or to improve the end-of-pipe capture of microplastics. Think, for instance, of market-based tools, subsidies, and the like. So this is all from me. Sorry I was a bit long, but essentially the key message being here, policymakers have a range of policy tools available that they can implement to solve the issue. We know that knowledge gaps are still an issue, but they should not justify delay in action, because there are already interventions that we can take today. I thank you for your attention, and I'll be happy to take any questions.
Thank you, Elena. It's a very nice presentation and insight into the policies of OECD countries and other countries who are using textiles. Good. And one thing is that you talk about is there any policy related to the rubber which is synthetically produced, and like rubber trees they earlier used to have in Malaysia and Indonesia, they collect the rubber. And then that is having any differences, synthetic rubber, plastics, and they produce from that?
Yes. Thank you for your question. So for the purpose of our report, we did not really distinguish rubber, natural rubber from synthetic rubber, because, well,
maybe it is
yeah.
eco-friendly, I don't know, and that's what I'm asking. The natural rubbers may be eco-friendly, that's what I'm asking.
Yeah, absolutely. But that's not within the scope of our report.
Okay.
So we didn't look at the specific, health impacts of different materials, because that's not within our expertise.
Yeah, that's just because you talk about that, research and development and the policy and the do you expect that in Horizon 2020 in the European Union, this plastic research will be the main theme in future?
I would suppose so. The European Union has just approved new targets in 2021 to mitigate plastics pollution. One of them being specific to microplastics pollution. Now I can't remember if the target is 2035. I don't remember exactly the target here, but if I don't remember correctly, the aim is to reduce microplastics emissions by 30%. And in order to do that, I assume there will be a lot of research required into mitigation options.
Yeah, that's right. Because source reduction is very important, because even in the Chennai flood, we found that wherever there is a plastic, there is waterlogging is more. Okay, one more question is for you from that. All textile industries have to introduce some level of testing to qualify their textiles before they bring them into market, or only synthetic textiles?
Absolutely. Well, policy measures are all to be discussed. Nothing has been introduced yet. But one of the key messages that we got from the textile industry during one of our workshops is that this is not, you don't want additional requirements to become a hinder for industry. And on a second level, you also have to consider that although we're considering introducing further requirements, mostly in OECD countries, in fact, most of the production occurs in non-OECD countries. So it's going to be challenging to request that something which is not yet an emerging issue in in some emerging countries is integrated into testing and requirements done at the industry level. But one alternative that exists is that importing companies are responsible for taking care of either the testing or in some cases even the mitigation options. So one mitigation measures that has been suggested is that garments are pre-washed before they're put on sale. In some cases, this is already happening in some industries. The reason for this is that research has shown that a large quantity of microfibers are released during the first few washes, and so a preliminary wash before clothes are put on sale can reduce the number of microfibers that are emitted later on. Demanding that this occurs at the production stage might be challenging, but it could also be done in once after the products are imported.
Okay, thank you. I think that's thank you very much for your presentations and answering the questions. So we'll move on to the next presentation. Okay, thank you.